Welcome back. Today, we're getting right into the absolute bedrock of V-Engine's entire architecture, components and entities. I mean, this is the data foundation that makes everything else, all the high-performance magic, even possible. We're going to cover how V-Engine thinks about data, how it organizes it, and why this whole approach is the key to incredible speed. Let's get into it.
So I want to kick things off with a question that might challenge a core assumption for a lot of developers. What if your game objects just weren't objects at all? I know, it sounds a little weird, but this one single idea is what unlocks the entire performance model of an entity component system, or ECS architecture. You know, in the traditional object-oriented way of doing things, you've got these objects that bundle data and behavior all together. A player object has its health data and the code to take damage all in one package. Well, V-Engine completely separates these two things. An entity is literally just an ID number, and all of its data, its state, is stored in these separate little packets called components. And the behavior, the logic, that lives somewhere else entirely in what we call systems. We'll get to those later, don't worry.
And this really gets us to the core philosophy. We have to rethink game objects by embracing pure data. In V-Engine, data doesn't do anything, it just is. Now, this might feel a little restrictive at first, but trust me, it's the secret sauce for writing code that's way easier to debug, to serialize, and most importantly, to run in parallel. So what exactly is a component in this world? Well, it's nothing more than a plain old data structure. Seriously, just think of it like a C-style struct. It has fields that hold the state for an entity, position, velocity, health, but absolutely no methods, no logic. It's just a bucket for data. That's it.
And listen, this isn't just a guideline, it's a core architectural principle. This quote from the design docs really says it all. The purity of these components is totally non-negotiable, and that's because it's what makes the entire system work. It guarantees that when the engine needs to process data, it's dealing with a simple, predictable, and stupidly fast block of memory. So, to enforce this purity, every single component you write in V-Engine has to follow 4 strict, unbreakable rules. Think of these rules as the blueprint that guarantees our data is perfectly set up for high-speed processing, easy saving and loading, and parallel execution. Okay, so what's really cool here is how each one of these rules directly maps to a performance goal. Rule 1, no methods. Why? Because all the behavior, all the logic lives in systems. Rule 2, no inheritance. This helps us avoid those complex, rigid class hierarchies and instead lets us be way more flexible with composition. Rule 3, they have to be default constructible. This just means they can pop into existence with sensible default values automatically. And number 4, trivially copyable. Now this is the most technical, but it's absolutely crucial. It means the data is just a dumb block of bytes. The engine doesn't need any complex logic to copy or remove it. It can just blast that data around in memory at maximum efficiency. So we have these pure data Lego bricks called components. How do we actually build stuff with them? Well, that's where entities and archetypes come into play. This is how we start to build the fabric of our game world.
An entity all by itself is, well, it's basically nothing. It's just a unique 32-bit number. That's it. It doesn't have a position, it doesn't have health, it has nothing. It's just a handle, an ID. It only gets meaning and becomes a player or an enemy based on the collection of components you attach to it.
Now, you can create these entities in a couple of ways. You can talk directly to the low-level data store, which we call the registry. It's powerful, for sure, but it's a little bit verbose. Or you can use the approach we really recommend, the entity wrapper class. It just gives you a much cleaner, more intuitive way to add, get, or check for components on an entity.
And for all you performance-minded folks out there, here's the best part. That convenient wrapper class, it costs you next to nothing. We're talking a mere 12 bytes of overhead on a 64-bit system. That's a tiny, tiny price to pay for a massive improvement in your code's readability and just how nice it is to work with.
Of course, attaching a dozen components by hand every single time you want to spawn an enemy would be a total pain. And that's exactly why we use archetypes. An archetype is really just a factory function that bundles up a standard set of components. So you want a melee enemy? You just call the archetype, and it spits out a brand new entity with its transform, health, AI, and physics components already attached and configured for you. Okay, so we've built a world full of entities, and each one has its own unique combination of components. Now for the next big challenge. How do we find the specific data we need to act on, and how do we do it at lightning speed? I mean, really think about it. In a complex scene, you could have literally millions of components. A physics system only cares about entities that have both a transform component and a rigid body component. So how does it find just those entities frame after frame without grinding the whole game to a halt?
The answer is a really powerful system called Views, which comes from EnTT. That's the third-party library that really powers VEngine's core ECS. Views let you create these highly specific queries. You can ask for all entities with a single component or entities with a very specific combination of components. You can even exclude entities that have a certain component. It's an incredibly flexible and super efficient way to get exactly the data you need and nothing more.
VEngine takes querying one step further with its unique tag-first design philosophy. Now, this is kind of the inverse of how many engines work. You see, here, tags are the primary identifier, not some unique name. An entity must have at least one tag, but its name is completely optional. This allows for incredibly flexible grouping in querying, like finding all entities tagged enemy and melee and elite.
Okay, we've talked a lot about rules and structure. Now let's get to the big payoff. Why are we so obsessed with pure data and this specific component design? Well, it all comes down to memory layout and how it affects the single most important factor in modern performance, the CPU cache.
Right. Here's the crucial thing to understand. When your CPU needs data from RAM, it doesn't just grab 1 byte at a time. It grabs a whole 64-byte chunk. We call that a cache line, and stores it in its own super fast local memory. Now, if all the data your system needs for an entity fits inside that one chunk, it's unbelievably fast. But if it's bigger, the CPU has to go all the way back to RAM for more, and that's a huge slowdown. And that's exactly why these guidelines are so important. Keeping your components under 64 bytes is the sweet spot. If they get much bigger, you really need to think about splitting them up.
And this chart just illustrates that difference perfectly. A cache hit, where the data is already waiting in the CPU's local cache, is orders of magnitude faster than a cache miss, where the CPU literally has to stall and just wait for data to be fetched from main RAM. Keeping components small ensures we get more of those beautiful, fast cache hits.
So, a really practical technique to achieve this is called hot/cold splitting. It's pretty simple. You look at a large component and you figure out what data is accessed every single frame. That's your hot data. Then you find the stuff that's only needed once in a while, like configuration data or something. That's your cold data. You just split them into 2 separate components. This keeps that hot, performance-critical path as lean and as fast as humanly possible. So let's do a real quick recap of the key takeaways here. First, components are pure data, no logic, period. Next, entities are just IDs that group those components together. Archetypes are our factories for making pre-configured entities easily. Views give us powerful, fast queries to find exactly the data we need. And all of this serves one ultimate goal, a memory layout that is absolutely critical for top-tier cache performance.
All right, so we've laid the entire data foundation. We have our materials, we have our blueprints, and we have our organizational principles. But right now, it's all static. It's just data sitting there. In the next explainer, we're going to build the engines of logic, the systems that actually bring all this data to life.
Which leaves us with one final thought to chew on. If all this carefully structured data is just a blueprint, a collection of state without any action, then how in the world do we forge a living, interactive, and dynamic world from it? We'll explore that very question in our next explainer on systems. I'll see you then.